Oh, you're welcome, our viewers. And we are back in paper 2. And this is a lesson about the illustrative examples to the connected particles that we looked at last time for simple connection. And here comes an example where we are saying that blocks A and B of masses 2 and 3 kilograms respectively are connected by light inextensible string passing over a smooth pulley as shown below. Block A is resting on the rough plane. The plane is rough, note this, inclined at 30 degrees to the horizontal, while block B hangs freely, as you can see. When the system is released from rest, block B travels a distance of 0.75 meters before it attains the speed of 2.25 meters per second. So they want us to calculate the acceleration of the blocks, but we may need to draw or to redraw this so that we clearly indicate all the forces. It is inclined at an angle of 30 degrees. This is B. It will have a weight of 3 grams because here we're having 3 kilograms as B. And this is our A, which will have a weight of 2 grams. Should have 2G cos 30 degrees. Shall have the normal reaction. And here we shall have 2G sin 30 degrees. This is the tension. And then here is the tension because it is one string. Of course, here we shall be having for the direction of the pulley. All right, we shall see how to get this. Then, since this weight is heavier, since this mass was heavier than this, the body is accelerating in its direction, like this. So A. But remember, they are saying that block A is resting on a rough plane. So if A is resting on a rough plane and is accelerating upwards, meaning that the frictional force would be applying downwards, or it will be downwards. So we can look at independent or individual forces by looking at for 3 kilogram mass. For 3 kilogram mass, 3G is heavier than T. The body is accelerating downwards, meaning that this force is counterbalancing this. So we shall have 3G. Here we shall see that the net accelerating force is equals to 3G minus T, implying that if we apply in the F is equals to MA, we shall have our force 3G minus T is equals to mass, which is 3, times acceleration, which is equation 1. Then for T kilogram mass, for the 2 kilogram mass, the net force is equals to, now for this case, the net force is going to be, since 2 kilogram mass is also accelerating upwards, so it will be T, which is in the direction of motion, minus the summation of these ones which are opposing, F and 2G sine 30. So it is going to be T minus 2G sine 30 minus F. Remember, you would have added them, but we are subtracting. So I opened and it really gets to be this. Then, which means that the overall equation is going to be T minus 2G sine 30 minus F, but F is the same as mu R, so it is going to be mu, but my R is equal to 2G cos 30, so mu 2G cos 30, then this is equals to a mass which is 8 times acceleration. So when we add equation 1 and 2, when you add equation 1 and 2, T's are going to cancel, so we shall be having accelerations will be 5a after adding is equals to 3G, all right, 3G minus 2G sine 30 minus 2G mu cos 30. 5a is equals to 3G minus sine 30 is a half, which will cancel with these two, so we shall be remaining with minus G, then minus cos 30 is √3/2, which √3 will cancel with the 2. So I'll be left with the G mu √2, right? If I call this one my equation 3, you see, they are saying that when the system is raised from rest, block B travels a distance of 0.75, block B. So I'm going to note and say, when B is set from rest, it travels a distance. Remember, from at rest, it means that the initial velocity was 0. And it attained a speed of 2.25, meaning that is the final velocity, 2.25. But it traveled a distance of 0.75. So applying this all in V squared is equals to U squared plus 2AS. It would imply that 2.25 squared is equals to U squared, which is 0, plus 2 times A times S, which is 0.75. Here, 2.25 squared is going to be equaling to 0.75 times 2, that is 1.5A. When you divide through by 2.25 squared, you get your A 2.25 squared over 2. 2.25 squared divided by 1.5. So your acceleration is going to be equaling to 3.375 meters per second squared. All right, since I've gotten the acceleration, I can easily get the coefficient of friction from this equation 3. All right, I can get the equation, the coefficient of friction from equation 3. So what am I going to do? I am going to say, let me do this. From 3, which equation 3 is 5A is equals to 2G minus G mu √3. I've gotten A already, so it will be 5 times 3.375 is going to be equal to 2 times g, which is 9.8, minus mu times 9.8 root 3. So this is the same as 16 here, 0.875 is going to be equal to 19.6 minus 98 root 3. So mu. All right. So this is going to be equal to 98 root 3. Mu is going to be equal to 19.6 minus 16.875. It's going to be equal to 2.725. I think that my mu is going to be 2.725 divided by 98 root 3. So our mu is going to be 0.16. Now for the case of Roman 3, where you want us to get the reaction, we shall do that using the parallelogram law of forces. We have something like this. I always encourage you to draw using a ruler. So here it was 30, implying that this angle is 90 minus 30, which is going to be 60. And my normal reaction, or my R is here. So this is T, and this is T. What does it imply? It implies that if we use parallelogram, law of forces, we are going to have R squared is equals to T squared plus T squared plus 2 times T cos 60, the angle with which R is respective. So we are going to have our R squared as 2T squared plus 2T squared times a half, which is going to be equal to T squared plus T squared, even here, plus another T squared. So my R squared is equals to 3T squared, and therefore my R, if I take the root, it is going to be T root 3. I need to first get T. If you get equation 1 from equation 1 is saying that it was 3G minus T is equals to 3A. So by this, I can get the value of T. So my T is going to be equaling to 3G minus 3A, which is going to be 3 times 9.8 minus 3 times acceleration, which we got as 3.375. So this one will give us our T as 33. No, our T is going to be equaling to 19.275. After getting the value of T, we substitute here to get R. R is equal to T root 3. So it is going to be 19.275 root 3. What times root 3? Which is going to give us our normal reaction as 33.4 newtons. And that is what we shall have. Wow, from here, that is the first illustrative example that we can have done. Then, Can do one more example. Can do one more example. Let's see. The diagram below shows a 12 kilogram mass on a rough horizontal plane. The 6 kilograms and 4 kilogram masses are on rough planes at angles of 60 degrees and 30 degrees respectively. Then these masses are connected by, let me say, to each other by a light inextensible strings passing over a light smooth smooth fixed pulleys A and B. This is a sketch. So we are going to integrate it further as we do the solution. So this is given as angle 60, and this is given as angle 30. Here is a pulley. Here is another pulley. And here is a mass, 4 kilograms. And here is a mass, 12 kilograms. And then here is a mass of 6 kilograms. AB. Then they are saying that the planes are equally rough with coefficient of friction 1/12 if the system is released from rest. Find the 1, acceleration of the system. 2, tension in the strings. Interesting. Solution. Now, for this case, when you're given a sketch, this is not the final. Don't start talking about forces using this. You have to sketch yours and indicate all the forces that are supposed to be indicated. So what do we do? What we have to do is to make sure that we redraw and then we see. I'm having that. And here is inclined at 60 degrees, while here is inclined at 30 degrees. Here is the mass. And this mass has been given as 12 kilograms, meaning that its weight is 12 G. And if I have here a pulley, here I will have the mass the string connects to. And this mass is 4 kilograms, meaning that its weight is 4 G. If its weight is 4 G, then it means that, of course, it has normal reaction. Let me call it R1 with respect to this mass. It implies that here it will be 4G sine 30, indicating these forces helps you resolve better. Then here, this force will be, use a ruler strictly. This force is going to be 4G cos 30. If this is my reaction 2, I'll call this one here reaction 1. So you have a pulley. So here we are having weight of 6G. Since we have 6 kilograms, so the weight will be 6G. And the normal reaction is going to be R1, implying that here you have 6G cos 60, while here you have 6G sin 60. Now, the tension is R2, meaning that this one, the normal reaction here would be R3. The forces here are going to be, since this weight is heavier than this 4G, 6G is heavier than 4G, meaning that the acceleration, the system will be accelerating this way. So it will be A meters per second square, this side. And here, the system is accelerating this side. So the system is going to this side because this weight is the one moving the system. So it is going to be acceleration, meaning it is accelerating upwards here. Then if I call this one T2, And I call this one T1, meaning that here is also T1. Here is also T1. No, T2 here. Sorry, T1, then T2, something like that. Now, we need to also know that the system is, on the rough table. They're saying that 12 kilogram mass is on the rough horizontal plane. Before I go to this mass, you need to also know that this 4G, they are saying that equally, the planes are rough equally, meaning that this plane is rough, this plane is rough. So if the system is accelerating this side, it means that our frictional force F1 would be moving this side. Because the system is moving down, so the frictional force will be moving up. For this case, the system is moving up, so the frictional force is moving down. Let me call it F2. But remember, this F2 I am writing is with respect to this mass, and it must be on the body that is in contact with the mass. So it is on the plane. Then here also, this 12 grams will be also taking this direction, but it is going to be opposed by the frictional force, and we call it F3. Now with this kind of sketch, you can talk about all the forces. I'm going to get the resultant forces, then I'll get everything on the other page, because this page may not favor me get everything. So for example, if we begin with 6 kilogram mass, the resultant force, let me get the resultant force. The resultant force for 6 kilogram mass, 6 kilogram mass is moving down. It implies that this 6G sine 60 is opposing these two. It is the heaviest force. It is moving the system downwards, meaning that it is counterbalancing the summation of these two, which are opposing. Remember, we said that the resultant force is equal to the force in the direction of motion, that is 6G sine 60, minus the total opposing force, which is T1 plus F1. So let me say that this is the same as 6G sine 60 minus T1 minus F1. F is mu. F is mu, but remember, mu has been given as 1/12. So it is 1/12. All right, mu has been given as 1/12 because it is mu R1. But R1 is the same as 6G cos 60. So it is going to be 1/12 times 6G, then cos 60. That is the first force. But remember, this force is equals to mass times acceleration. So it will be mass, which is 6 times acceleration. I call this my equation 1. Then if I go to a 4 kilogram mass, the resultant force is going to be equal to 4 kilogram mass. Since it is moving up, it means that this tension T2 is now the pulling force T2. Since the body is moving upward, so this T2 is the pulling force, but it is going to be counterbalancing F2 and 4G sine 30 because they are the ones which are in the opposing motion. So it will be T2 minus F2 plus 4G sine 30 degrees. So when you look at this, it would imply that T2 minus mu, which is a half, or rather 1/12, times R2, which R2 is 4G cos 30, 4G I'm looking at this, 4G cos 30 minus 4G sine 30. This is equals to MA, which is 4 times acceleration. I call this one my equation 2. Then for 12 kilogram mass, since the body is accelerating this side, I mean that T1 is overcoming T2 and F3. So it is going to be T1 minus F3 plus T2 is equals to mass, which is 12 times acceleration, which is A. So this is going to be T1 minus mu, which is 1 over 12. Then R3 is the same as 12G. If you look at this, so times 12G, then minus T2. This is equals to 12A. This is equation 3. So having these 3 equations, I can do my best. So from another page, I will say, from another page, I'm going to say that if I add those equations, equation 1 plus equation 2 plus equation 3, we are going to find that we shall have 6G plus 6G sine 60 minus, it will be a half G cos 60 minus a third G cos 30 from the previous, then minus 4G sine 30, then minus 20, minus a G, which is going to be the total of the right-hand side, which is 22A. So when you work on this with the calculator, 6G sine 30, sine 60, sorry, half G cos 60, third G cos 30, 4G sine 30 degrees. This one will all reduce to 16.24327742, and this is going to be going to 22A, meaning that A is, we divide 16.24327742, we divide it by 22, sorry, you get your acceleration as 0.7383 meters per second squared. That is the answer. Then they want us to also get tensions. So B wants tensions, but from equation 1, which is 6G sine 60 minus T1 minus a half G cos 60 is equals to 6A. It means that my T1 is going to be equal to 6G sine 60, right? Minus a half G cos 60 degrees, then minus 6A. But if you substitute, I brought this T1 this side, then I brought 6A this side. So my T1 is going to be equal to, I will just substitute 6G. We shall already substitute G with 9.8. Sine 60 minus a half G cos 60 minus 6 into 0.7383. So we're going to get your tension 1 as 44.0423 newtons. And if you look at equation 2 is saying that T2 minus a third G cos 30 minus 4G sine 30 is equals to 4A, implying that our T2 is equals to 4A. It is going to be equal to 4A plus a third G cos 30 plus 4G sine 30. Now, this is going to be equal to 4 times acceleration, which is 0.7383, plus a third G cos 30, and plus 4G sine 30. Putting this on the calculator will get you T2 as 25.3823 newtons. Remember to use G as 9.8. It will always be given on the question paper, so don't worry a lot. So those are two examples here that can guide you. Those are two examples that can guide you. I'm going to give you one trial number. I'm going to give you one trial number that you can do at your own time. So all our viewers, this is our trial question. Based on the other general ideas I gave in the previous videos, one can do this question. One can do this question. So I'm going to mute my audio. Going to first stop, then I first write this question here. All right, so that is how our question is. Let me hope for the best trials. I wish you all the best. Don't forget to tell a friend by sharing a link to subscribe for the daily notifications about the videos we shall be sharing. I wish you all the best. God bless you as you watch.